Hello rocket builders! Today we're going to talk about 3D printing. It's not just for toys and trinkets, we can also use it to great effect in rocketry. All that's next. Remember folks, I've been certified to build and fly rockets up to level 3. If you don't have these qualifications, you might want to consider a simpler project and perhaps join one of your local or national organizations. Rocketry is a very safe hobby if you follow some very simple guidelines. So 3D printing is an innovation that has really unleashed creativity upon the world. And it's certainly affecting the hobby of rocketry like it is any other. So what I want to do is cover some of the things you can use it for, where it's a good idea, and where perhaps it's a little less so. Okay, so as we saw, the standard first print for a lot of people is just a little shelf toy. It doesn't actually float, it doesn't do anything, but looks cool. And a lot of 3D printing definitely does that. Now, when I did my Saturn 1B project, there are a lot of things that I use the 3D printer for, and that's why we're covering this as part of the Saturn 1B build series. There are some structural parts. So when you first think about 3D printing, you think about making nose cones, about making fin cans, things like that. They certainly can do that. In the Saturn 1B, as we'll see, the command module, which is effectively the nose cone, and the launch escape system are predominantly 3D printed. Not entirely, but mostly. So it gives you the ability to create something that might have been pretty difficult to create otherwise. It's just a matter of getting the drawing right in the computer, submitting it to the 3D printer, and you have your part. One of the things you may not have considered are non-structural components. So for example, sleds for your electronics. Okay, so here what I've done is I've built them into smaller ones, and in the Saturn 1B each module goes into its own little pocket, as we'll see later, but they can also be combined for more standard ones. So for example, the 4-inch rocket that I used for my level 3 certification, they can now be used in there. Okay, and in this one I've made a little bit of accommodation for the antenna of the ham radio transceiver. Okay, so if you're curious, this is a telemetrum and a RRC2 electronics module. Okay, so this is actually the first thing I did with 3D printing when I did my level 3 project. Now, also on the Saturn 1B, I used it for a lot of details. As a scale model, it's pretty large, and the details that would be really small in your Estes kit, for example, are significantly larger on the 1/23rd scale Saturn 1B. So for example, I used it for ullage motors, for retro rockets, for attitude control, for all of the details on the Saturn 1B, and it worked out pretty well. As you get serious with your 3D printer, one of the things that may surprise you is how much you use it for things that don't go on the rocket, but are still essential to the build. Tools. So as an example, a very simple low power cradle. You can make this out of balsa. I did this in 3D for a few reasons, including the fact that the printer was here and the balsa wasn't. But this is one example. For the Saturn 1B, I used it for the sanding templates. So we saw that in the last video when I was making the fins. But I also used it for holding the engine skirt both in the correct location and in the correct shape while I was putting the fins into the Saturn 1B. We haven't seen that yet. We'll see that when I get to the assembly of the fin can. All of those things required custom tools, and the tools would have been very difficult to build by hand and pretty trivial to draw in a CAD program and print on the 3D printer. Okay, so that brings us to the printer itself. You're going to have to learn some things when you start 3D printing. Just for the printer itself, when you're selecting a printer, you do have to look at features. You have to think about what it is you're going to be using it for. Some simple things like how big a print can I make in terms of the X, the Y, and the Z, because you're thinking in 3 dimensions here, not just 2. Most of the things you're going to make are pretty small, so I mean like a sled like this is pretty common. So you don't necessarily need a lot of height, but for the Saturn 1B, I am pretty much at the limits of the height of what this printer can create. So if you are making some larger models, that might be something that you want to consider. Materials, we'll talk about that in a little bit later. Some materials require a heated bed on the less expensive printers. That doesn't exist. So that's something you want to consider as well. Also the mechanics of the system. It does require some maintenance. We'll talk about that in a moment. So you want to get something that's reasonably solid and sturdy, especially as you go up in the vertical direction with printing. You want a frame that is pretty consistently stiff throughout the whole range of motion. One of the things you have to worry about when 3D printing is how the printer actually works. If we take something like this, it doesn't print it all in one go. What it does is it slices it into very small layers, about 0.2 millimeters in my case, and just layers them up, adds them piece by piece. So once you've drawn it in your CAD software, you have a slicer program that creates those slices and passes that on to the printer. Okay, so you'll probably get something with your 3D printer. It may or may not be the best one available, and you may find that you're upgrading to a separate package at some point down the road. But in this case, for example, we got the Maker software, which was pretty decent as starting. I have since moved on to another package, but that one lasted me quite a while. So you are going to have to learn how that stuff works. CAD. You need to be able to design your models. There are a few ways you can go. There are a number of existing models out there if you have friends who make models and so on. For example, Thingiverse is a location where you can download a number of models that were developed by other people. I haven't gone in and looked to see what's available for Rocketry. I know there is some stuff in there, but most of the stuff I've done on my own. So let's talk about software packages. There are a number of CAD packages out there that can do the job, and you're going to have to look around a little bit and decide what's right for you. There are some commercial ones, obviously. They tend to be very expensive, but they're the same ones that you would use if you're in an engineering firm doing professional computer-aided design. And that's why the prices are high. And then you have some that are kind of quasi-commercial. So for example, one of the more common packages used in 3D printing is one called Fusion 360, which is a commercial package and it's supported and all that interesting stuff. But they do have a license available to the tinkerer, to the very small business. I think it's if you make less than $100,000 a year, you can get an annual free license. How long that's going to continue, it's been on for a while, but they do have the option of taking that away at some point in the future, so that's something to consider. Fusion 360 is also cloud-based, so all your models are stored on their systems, which is not something I particularly like. I like to have my own. Another commonly used piece of software is known as Tinkercad. Now this is useful for the beginner, and that's who it's aimed at. And the premise here is it's a web-based interface. You design all your parts online, and you can build them quickly, simply, and then either download the design file or ship it out to someone else to print. A very good place to get started. Now, I didn't like that because when I was doing my design work, a lot of the times I was traveling. I had intermittent internet access, and as I've mentioned before, I'm not real keen on storing my stuff on someone else's computer, so I don't really like cloud services in general. So I started with a program called OpenSCAD, and again, it's very commonly used within the modeling community. It's a little more programmer-oriented. Being a programmer, that wasn't a problem for me. But if you're not good with programming, it may not be the best option for you. It is really simple. but all things are simple if you know what you're doing, I guess. It is open source, and that is very nice. It is on your local machine. It supports multi-platform, so Windows, Mac OS, Linux, they're all supported. The one I wound up using was one called FreeCAD. Now this is also an open source project, and it is supported on Windows, Mac OS, and Linux. So that multi-platform option was very attractive to me. The fact that it wasn't web-based means I could use it on my local machine in a hotel in a very small town in a very obscure country. So that's the one I wound up going with. At the time I was working on my Saturn 1B, the features I needed weren't in the FreeCAD program. They were actually in the development build. So I was actually working from a not even beta copy. I downloaded the source code regularly and rebuilt it on a regular basis in order to get the features I needed. I did encounter some bugs which got fixed and so on. So the community was very helpful there, and all those features are now in the generally available product, so I don't have to go in with a software debugger anymore. It actually works quite well as it is. And if you look at the design files, I have the link in my website. Most of them are actually in FreeCAD. Now I'll talk about FreeCAD a little more later, but the nice thing about FreeCAD is you have a number of options of how you build things. Most of what I did was using what's known as sketches, which can then be either extruded or subtracted from the current design. So it gives you a little more than just the shapes of cylinders and cones and things like that. But they also had a programming interface, which when I was going into the launch escape system, the tower in particular was a pretty complex design that was easy to program and would have been very difficult to piece together using parts. So I wound up writing a macro that would generate that structure for me. So in this section, I'm going to talk about things they don't tell you. These are the things that may surprise you as you start working with it, and certainly something you want to be aware of before you go out and invest a lot of money into a 3D printer. So let's talk first about materials. PLA, polylactic acid. This is the most commonly used material. It's easy to work with. It actually prints quite well out of the box. Yeah, so there are some issues with this though. It comes in many colors, which is nice because you can't paint it. You will see all these videos about painting this, but that's for parts sitting on a shelf, not for parts flying on a rocket. You may be familiar with some of the painting issues with the high impact polystyrene nose cones that we use. Well, this is even worse. It's also not completely smooth. With the layering, you do get layering effects, and if you look closely at the sides, I'm not going to show you with a close-up with the camera because you probably can't see it, but there are definitely some layer stripes as this thing gets printed. So it's not as smooth as the parts you were getting at. You can sand them. You will never get them as smooth as what you currently get with your plastic and cardboard and balsa and so on. So those are all things you need to be aware of. Another surprise about PLA for a lot of people is its glass temperature is 60 degrees Celsius. And what that means is if it's inside a rocket in the Black Rock Desert in the baking sun for hours on end, you may see some deformation as the plastic basically melts. Okay, so that is one of the known limitations of PLA. That being said, I don't fly in the desert. Flying in upstate New York, even though on hot days I haven't experienced that melting myself, but I have seen on the forums where people have experienced that with PLA. So depending on where you're flying, that is something that you want to consider in terms of materials. Now, the next common material is ABS. And that's something we certainly are familiar with, but you need to be aware that ABS has many formulations, so it may not behave exactly as your plastic model kit, for example. It's not something I've experimented with yet, so I don't have a lot of first-hand knowledge of it, but ABS is a lot more troublesome to print with. Most 3D modelers have actually given up on ABS, but they're not Rocketeers, so their reasons for doing so are simply that PLA is so easy to use, for example. I don't know how well it's going to paint. I don't know how well it's going to glue. Now, typically when they talk about using ABS 3D printed parts, they use a slurry of ABS plastic and acetone, and that can help smooth it out. So you can get a smoother surface than you can with the PLA. And it can also be used as glue. I'm not sure if the typical modeling cements are going to work very well with 3D printed ABS. Again, I haven't tried it. If you have, leave a comment, and I'd like to know your experience. The other thing they don't tell you about is maintenance, and this is very important. This thing is a pain in the butt. Whenever you want to print a part fast, you're instead going to have to do some maintenance on your 3D printer. And it doesn't matter what model you get. Certainly the higher end ones, you're going to have more run-of-the-mill issues than you would with a less expensive one, but most Rocketeers are not rich. We tend to go with less expensive ones, and that means a lot of maintenance. As you're viewing these YouTube channels on 3D printing, and there are many, I encourage you to do so, it's something that they don't really talk about a lot except for the videos where they talk about maintenance. Now, the issue I had is figuring out what I needed to do. So I get a problem. It would take me an hour or two to figure out even what the problem is, and then I find the video that gives me the quick and easy solution. So there's going to be a lot of learning there. There's going to be a lot of downtime when you really want to be building rockets, but you're going to be working on your 3D printer instead. Remember, a lot of these YouTube video content providers, 3D printing is their hobby. Well, the sort of issues you get, well, I mean, there's a nozzle there that has plastic coming out. It clogs, it jams. In this particular printer, it's not very well designed to remove the nozzle to maintain that. Other printers are actually a lot better, but this one is just, the structure looks nice, it gets in the way. But it is structural, so it's important. You do have to do some calibration. In the owner's guide for this one, when I first got it, there was no mention of calibration. Now, as I took it out of the box, it worked pretty well, but later on when I started doing maintenance on the nozzle, it got out of calibration and I wasn't getting good prints, and I had no idea why. Again, it took several days of research to figure out what the problem and the solution were. So be prepared for things like that. You can have mechanical issues. These are mechanical machines and there's a lot of vibration. Things like nuts going loose, or just needing to adjust the tension of some of the belts that move the pieces and so on. Greasing up the rods and the screws. I mean, these are all bits of maintenance that you need to do. Wiring issues. These are also computer controlled. There's a lot of wires coming down to the print head for the head heater, for the thermistor that measures temperature, for the fans, for all of those things. And the wires, as they're moving, can become disconnected and you can have issues. So you need to be able to debug some of that stuff. In my particular case, the heated bed failed. So I basically had to replace the heated bed. I upgraded it at that point to give me a better quality piece, but that involved buying a new piece of glass. It involved getting a new silicone heating bed. I did some rewiring so I can get some extra power to that heated bed, and yeah, so you just get a whole host of issues. So again, remember, if you're going into 3D printing is your hobby. Okay, so you want to do 3D printing, but you don't want to mess with a 3D printer. There are alternatives out there. There are services where you can submit your design files and they will 3D print them for you. They work very well. As I was having issues with this machine during my Saturn 1B build due to time constraints because I was traveling a lot, I did submit some of my pieces to be 3D printed. They work very well, but the problem there is a lot of times this stuff is being prototyped, so your tolerances may be slightly off or whatever, and then you have to send it out again with the corrected file, and that has a turnaround time as well. It's also not necessarily cheap. Certainly some parts can be, but when I looked at the command module for the Saturn 1B, which I did have 3D printed, it was expensive both because of the volume of plastic used as well as the amount of time required to print it. As we'll see a little bit later, it's a pretty complex print. The result I got was magnificent, but it wasn't cheap. So, 3D printing. There's a lot of downsides, but even with all of them, I wouldn't give up my 3D printer. This thing has opened possibilities for me. It makes you think a little bit differently about how you're going to build it, not just in terms of pieces on the rocket, but in terms of the tools you're going to use and what you can make as manufacturing aids and things like that. I mean, these are just some of the things that I have, but as I was going through, even when I was having problems with the printer and the quality wasn't good, for making a tool it was still fine, and I created some very quick and dirty tools that proved quite useful. I'm sold. I don't recommend getting the cheapest printer. Certainly there are some good ones out there now in what is considered the mid-range, so about $500 to $800 US. And they are quite good, but you're still going to have some maintenance issues with them. At some point you're probably going to be upgrading them. Even simple things like, well, my spool holder here, I had to put a little disc on there to keep the spool from flopping over and things like that. So a very common thing when you get a 3D printer is just creating upgrades for your 3D printer. But it opens a level of creativity and possibility that you just, it's hard to match. So 3D printing, thumbs up. Just have your eyes open before you get into it. So as always, if you've liked the content that I provided here today, subscribe, and that'll keep me producing more. If you have comments, if you've used different materials, for example, like ABS, or if you have any hints or just general recommendations about 3D printing, leave a comment below. And as always, have fun flying. Thank you.